Welcome to example number 2. In example 2, we're asked to determine the direction of the magnetic force that's acting on different charged particles in different magnetic fields. In this example, we're going to be utilizing the right-hand palm rule. Let's review that. So if you recall in the notes, the right-hand palm rule, you use your fingers as the direction of the magnetic field, your thumb in the direction of the movement of the charge, kind of like you're hitchhiking, and your palm is in the direction of the force, like you're going to slap something. So back to our example. Let's take a look at A here. And in this case, we can see that the magnetic field is pointing towards the top of the screen. So I'm going to be pointing my fingers towards the top of the screen. My thumb is towards the right of the screen. So if I use my right hand palm rule, my fingers up and my thumb to the right, I'll see that my force, or my palm, will be facing towards you. All right, so therefore the force is coming out of the screen. And out of our screen is along the z-axis. So therefore, there is our direction of our magnetic force, F sub B for the magnetic force. Okay, let's take a look at now example B. In example B here, we have a magnetic field that is pointing towards the top of your screen. The velocity is pointing along the z-axis, which is really towards you. So by using the right-hand palm rule, your finger is pointing straight up. Your thumb is out towards you, and you can see that your palm will be facing along the left-hand side of your screen, which is along the negative x-axis. So here we're going to draw our force here in this direction. So that is our magnetic force. It's along the negative x-axis. Okay, now we move on to part C. I'll just move this over a little bit so you can see it here. And in part C, we have a field that is pointing along the x-axis, positive x-axis, and the velocity of the particle is coming towards you. But if you look closely, you should notice that there is a negative charge here. Because there's a negative charge here, that means that you have a choice here, I suppose. If you use your right hand, you're really going to be getting the answer for a positive charge. So let's do that. Anyhow, your finger is to the right, your thumb is towards you, because that's the direction of the velocity, and your palm faces upwards. That would be the answer if you had a positive charge. However, this is a negative charge, so we'll be doing the opposite of that. So the magnetic force will be along the negative y-axis. So it'll be along here. So that will be our direction of our magnetic force. So you could use your right hand, but then you have to remember that the direction is going to be in the opposite direction that you determined for a positive charge. I personally prefer to use the left hand. So your fingers are to the right, your thumb is towards you, and your palm will be facing downwards, and that's the direction of the magnetic force. So for right hand, you're using that for positive charges, and for left hand, that would be for negative charges.